right, welcome, ladies and gentlemen. My name is Brian McLogan, and I am a little scared. I'm working out the new software for YouTube. It's not really new, but it's one of the new encoders that they're transitioning to. So I'm trying to give this a shot on my open Q&A live stream. And so I do apologize if some of you from my previous links maybe are not connected over here. Because I wanted to try it on this new stream, but I do see that you guys have, at least the chat is coming in, and I did do a live stream earlier today. I wanted to cover the quiz. Right now we are just wrapping up our analytic trigonometry. So we're going to be taking quiz 2 this week, and then we should be taking the test, but we're actually I'm going to kind of add one more lesson in. So we're actually not going to take the test on analytic trigonometry until next week. But I will have, I think I said last week I was going to try to do a live stream. I just couldn't do it, but I really do need to get another live stream in for our second half, our second quiz for analytic trigonometry, which was covering double and half angles. But I think I'm going to cover a couple of those questions today. So on the docket for today, I do see you guys joining in. Sailing Cam, I see you. You don't need to add hi more than once, but hello. So what we have on the docket here for today is, let's see, we have a piecewise functions. We have the graphing a trigonometric function. Oh, that's the same. Oh, another graphing trigonometric functions. Well, I can maybe open that up. Well, I'll maybe do another one since that's the same. But yeah, I had 2 students, I guess, asking me for sine. So I guess there's a big demand for graphing sine. Are those both to be? I don't want to divide up by 2x by both those times. None of those are fun. All right, well, I guess I'll just do, I believe that's both what they had. So either way, I'll do a rough sketch. We're going to solve an exponential equation. We're going to evaluate using the difference formula for tangent. We're going to do the double angles. I just decided to do these 2. And then we'll talk a little bit about a function. Yes, Andrew V, guys, you don't need to add more than one hi. Just one is perfect, and I'll be more than happy to get onto the chat. Mr. Beast is back again. Thank you very much for the super chat. Find the distance between 30 degrees and 330 degrees. There's a lot of distances that are between 30 degrees and 330 degrees. So I'm not sure if I follow your question, but if you want to elaborate, Mr. Beast, I will be looking out for you. Fitz says, did you hear about Kobe's death? I did hear about Kobe's death. Very sad for him and his family. It's one of those kind of tragic situations, one of those things where you just don't, it's crazy. It's crazy how unexpected things like that, can happen. And, that's a part of life, but it's a really sad part of life. So he was a really good basketball player. I think I respected him on the court and everything that he really kind of stood up for and stood it. And so, yeah, it's a sad day, definitely, for Kobe's family, fans, the basketball community, and stuff like that. But I did think he was a really, really good basketball player, and he was a joy to watch. So yeah, it's sad, definitely that, especially just for everybody in the I think it just everybody else that was in that crash and all their families was on. So it's in the unit circle. Yeah, I get it, Mr. Beast. Thank you very much for the second super chat. I'm not really sure what you mean, like what your question is though. Like, are you trying to evaluate on the unit circle? And if so, like what would you like me to evaluate for? Like trigonometric functions, we can do that, or anything else. Obviously, guys, I want to add in any other additional questions that we will possibly be going on. I have till 7. I try to always make this chat here about roughly around 30 to 40 minutes. So just kind of let me know what you guys think about this. And yeah, see, I don't know why the thing I don't like about this, as far as this new thing, is it keeps on disconnecting my chat and then it reconnected me back again. But it seems like everything is going good. So I'll just actually, I don't want to check that. So see, find the distance between 30 degrees and 330 degrees. Oh, well, the distance between 330 degrees and 330 degrees would be 300 degrees, Mr. Beast. Maybe that's what you're asking for. But again, let me know. It says I have excellent stream health, so I'm not going to worry about that. So, all right, I'll just kind of keep on going through. Ivan Ever says, do you have calculus videos, Mr. McLogan? I am kind of on a rough start. Yes, I do have calculus videos. Currently, right now, I am teaching pre-calculus, but I did teach calculus for a couple of years, 2 years ago. So I recorded, of course, everything in videos and playlists, and I posted them up on there. No, T-Rex, I don't think he's the real Mr. Beast. I think there's a little bit of a space between the Mr. and the Beast. But that's okay. I still really, really do appreciate the super chats, and I don't care who you are or what your name is. I am happy to help you guys out with your math with a super chat or not. Marcus says, thank you for your videos. Hey, and the person who is pretending to be me is even super chatting myself. So yes, obviously I will take those. Well, thank you very much, Marcus. I really do appreciate. I am happy to help you out, and I'm glad my videos have helped you out so far. Yeah, Ethan talks about the math SAT. I don't have anything on actually I do have some like older videos on the math SAT. But probably nothing any current. That's probably something I'm going to want to keep on working on through. All right, and let's see. Serge says, RLP Kobe, can you please explain? Tell me how to do elimination and substitution with fractions. And Riley says, I have looked at your channel for the beginning of basics geometry. I do everything, guys. The best way to find a video, in my channel, because I have so many of them, would be to go to the go to the playlist portion. And then if you can see, I kind of have all my playlists organized in Algebra 1, Algebra 2, geometry, and so on and so forth. So as far as substitution elimination with fractions, I have videos on them. As far as, basic geometry videos, like with transversals, I have videos on those. But I think the easiest thing to be able to find those is be looking at my playlists. And then can you explain a proof of parallelogram? I can't. It's okay. I'm not sure. I mean, there's many more proofs. California, it's okay. Everybody's going to take in their grief, different ways. I mean, you guys are joining me for this super chat, so I am more than happy. I'm just appreciative that you guys are joining in. But I also know that, a lot of you guys were fans of Kobe. So it's perfectly fine if you guys want to, give a little respect for Kobe on the super chat. And obviously, guys, I'm not going to be able to answer many more of your questions. But it's definitely, when somebody that's such a large public figure like Kobe Bryant was, and he had an impact and he was an inspiration for many people from around the world. So it's okay. I don't take any disrespect from anything, and obviously I'm just here showing up because I want to be able to help you guys out. And I really do appreciate you guys joining me on, again, a school night for a open Q&A live stream. And I don't know why I keep on talking for so long, but it is kind of always a good thing. I think the reason why is once I get into these live streams, I'm usually like exhausted by the end. So I can't really like talk too much. So therefore it's just kind of nice to kind of chat for a couple 10 minutes here before I get into doing some math. Cause yeah, once I start doing math, it's like I get in the zone and I don't really, can't really keep on looking into the chat and seeing what you guys are chatting up about. But yes, I do want to also, again, if you guys do have some questions that you want to add in, I am, 7 questions is probably going to take me to my limit. I usually try to keep everything between like 5 and 8. But if you do have some questions, please feel free to still add them into the chat. And, if there's anybody that's still in the chat that can maybe like help you out or answer or provide you into the next direction, that's greatly appreciated. All right, I'll just get to a couple more questions. So you guys are adding in there. Say hi to a couple more of you before I get in there. All right, says, I wish you were in my class. You helped me a lot. Well, very happy to be able to help you out. Kayla K shows, can you do math problems for me? Do you have time? Probably not for this live stream, Kayla, but if you wanted to make sure you just get into my community chat for next week, that would be perfectly fine. I'm happy to be able to help those out. And he says, trig videos. Yes, I do have some trig videos, and I will be uploading some more trig videos this week. Could you teach us multiply rational expressions? I can. Just make sure you send this up to me. Or just make sure you guys send questions. You know, it's very difficult for me to create equations or problems up on the fly on the live stream and, you know, to be exactly what you want. So if you guys do have something that you can send over to me, then that would be perfectly, you know, fine. That's what I have those community chats. That's why I try to always make those links on Saturday. So therefore you guys can, you know, get the link before we get going. All right, and okay, so what made you love math? I always just was interested in math. I was never good at math, but I always just was interested in the learning aspect and the creativity and the challenge of it. And it says, how old are you? I am 35, turning 36 on Friday, so my birthday is coming up. Well, good job. Who got 100? Good job, T-Rex. Good for you. That's awesome. It's always a good feeling to do very, very well on a test, especially a math test. So when you're doing triangle, is there any way of knowing whether you should use the degrees they give you or just subtract it from what you? I'm not really sure based on your question if I have enough to understand the context of what you're asking. So I'm sorry about that. All right. So Atlas. Patronus, OM, Brian's, Caitlin. I think this is still like my pre-calc, something like that. Yes, I'm still teaching pre-calc. Brian Locke says, hi, Mr. McLogan. Hello. What's your favorite football team? California. I am from Michigan. So my favorite football team is the Detroit Lions for the pros, even though it's very difficult being a Detroit Lions fan. That is what I grew up watching. So I am true. But obviously I live in Jacksonville, Florida now. So I obviously like to root for my hometown team as well. All right. I need help simplifying. So I'll go ahead and I'll look into that, Jason. Thanks for picking those equations. I need to go ahead and get started, guys, on these problems. So again, for those of you that are kind of joining in, we're going to be working on this piecewise function. Let's see, we're going to graph some trig. We got solve an exponential. I don't have a calculator with me, so I'm not going to get it all the way it doesn't look like, but I'll try to do my best. And then we're going to do some difference formulas, double angle formulas, and then determine if it's a function. So let's go ahead and get started, guys. If you do have some questions, again, add them into the chat. I'll try to see how much time I have at the end, how well I can explain these problems, and then we'll kind of go from there. All right, so week 4, open trigonometry, 15 minutes, a little chit chat, but that's not too bad. Let's go ahead and get started. So piecewise functions, something we haven't done in a while. This is a problem actually I made up because it was something that a student typed in and it wasn't fully completed. So I just kind of made one up and tried to see what we could do from there. All right. So the basic understanding to what you want to do for a piecewise function is really understand what we're trying to do here is we're really just trying to graph these 3 functions on the same graph. Now, obviously, we can't graph all of these 3 functions on the same graph because then they would overlap each other and it wouldn't be a function, right? So that's why we restrict a graph. And that's exactly what these little versions over here is. These are the restrictions. So what these represent is how the graph is going to be restricted. So for instance, the graph x squared looks like this, right? Or roughly looks like this. Well, now we're going to say only restrict this graph from x is less than -1. So let's say -1's right here, positive 1's are here. So here is my value from -1 right there. Right? So if I kind of take that open value, right, less than, not less than or equal to, it's going to be an open circle and then going to the left. So that's the portion of the graph that we want it to, that's going to be a part of this piecewise function. That means everything else I can actually delete, right? So we're only going to be working on the version of the x squared where it's less than -1. So now let's do the next graph. Y equals 3x. So again, that's going to have a y-intercept of 0. Let's go up 1, 2, 3, over 1, and down 2, 3, to left 1. So that graph looks something like this, right? Now, in this case, we're trying to graph this from -1 to +1. But now this is included, so it's going to be less than, or x has to be greater than or equal to 1, but less than or equal to +1. And it's going to be everything in between. So we're only going to actually include, the only portions of this graph that's included is from -1 to 1. So therefore, we can eliminate or delete the rest of it. And the last one is y equals 4 to the x, where x has to be greater than or equal to 1. So this one's a little bit more difficult to kind of see what this graph would look like. The 4 to the x, that's going to be like a vertical stretch. And so I'm not really sure as far as the points. I think the one thing that we want to make sure that we kind of understand about this graph is that there's still going to be a horizontal asymptote at 0 and a vertical asymptote at x equals 0. Now, the only thing is if you actually plug in 1, even though 1 is not defined, if you plug in 1, you would get the number 4. So 1, 2, 3, 4. So I guess that's going to be an open circle. Now, again, I know this graph, the shape of the graph looks like this, right? So as I keep on going to the left, as I keep on going up, it's going to go farther to the left. So this graph now is going to look something like that, where it's not going to intersect because you can see like from there to there it's crows. And again, I'm trying to do my best with what I have. But you can see how that graph is going to, typically going to keep the same shape, but everything over or larger than 1 is going to be going over there to the right. So because 1 would be at 3, 1 would be at 4, and then it'd be go to the right. So there you go. At least hopefully that's the best. The best advice I can do for piecewise functions is graph each function separately, then apply the transformations, and then go ahead and combine them. All right, for the next example, I have a trig function, and this is actually one I was kind of excited to do just because it's one that I don't really teach as much anymore in my class, and that's because we have a period of pi. However, I had to make this up because I'm not sure where the variable was, so hopefully this is helpful for the students. And I'm not going to do a very good job of graphing because technically in my class, I really just want the students to be able to identify, the period, the amplitude, the phase shift, the vertical transformation, the domain, and the range. And then from there, I want them to be able to sketch the graph. So I'm going to not really sketch a great graph for these two problems, but I will identify everything that I ask my students to do in the classroom and then just kind of give you a rough sketch. And the only thing that I will add for these two videos that I didn't do for my students is understanding the initial as well as the starting point and the end point of the initial period. So, but before we get started, I think it's really important to understand for the sine graph, with no transformations, y equals sine of x, for these two problems, it's really, really, really important to understand the graph is going to look something like that. Okay, so there's 0, pi halves, 3 pi halves, and then it's going to go down to -1, up to +1. Okay, so that's what we call the initial period. It starts at 0 and it ends at 2 pi. All right, and it has an amplitude of 1, where it goes up to 1 and down to -1. All right, so basically no matter what equation you're trying to give, when you want to identify the transformations, the first thing we want to make sure that we do is, though, make sure that we have our equation in our transformation form, where y equals a times sine of b times x. Oh, crap, I ran out of space. So let's do y equals a times sine of b times x minus c plus d. Okay, so again, if you understand these transformations, again, it doesn't matter which trigonometric function you're dealing with, if it's sine, cosine, tangent, or even cosecant, secant, or cotangent. Basically, the a, b, c, and d are going to affect the graph the same way. However, For sine, we really are only looking for the, one thing we're looking for, the amplitude. So in this case, the amplitude is the absolute value of A, which in this case is 1. So we're going to say that's going to be 1. The period is going to be the coefficient of our x, which in this case, you can go ahead and see it's going to be a pi. Although you can factor out, you just factor out the pi. So what am I doing? No, slow down. All right, first of all, let's just write it into the correct form first. I gotta slow down. It's been a while. It's been a winter break since the last time I covered this. All right, so this is gonna be x plus 1/3 plus 2. All right, here we go. So I have a sine of pi times x plus 1/3 plus 2. And now I can identify my a, which is 1, right? B is pi, c is 1/3, and d is going to equal 2. So now it makes sense for me to understand my amplitude can be 1. My period, if you remember, that's going to be 2 pi divided by b. So that's going to be 2 pi divided by pi, which is equal to 2. For this next one, you can see that that's going to be my phase shift. And that's basically going to be like how far you're shifting left or right. And that's going to be your c. But again, that only works is when you have that pi left out. Because if you didn't factor out the pi, you would say, oh, it's pi thirds to the right. But actually, it's 1/3 to the right. Okay, and then we have our last one is our vertical translation, which is going to be up 2. Okay, so that's basically the information that we need to be able to find. The only thing else that I really kind of give to my students to be able to figure out is letting them understand the start. So the start, to figure out the start, all we're going to do is take whatever's inside of our function, this pi x plus pi thirds, and set it equal to 0. So therefore we have pi thirds, so we have pi x, and then is going to equal negative pi over 3, divide by pi, and therefore x is going to equal a negative 1/3. Now, why is that thing x plus pi thirds? That's pi thirds to the left. What am I doing? Why did I say to the right? Okay, so again, that kind of makes sense here because x equals negative 1/3 is supposed to be to the left, right? If it's going to the left, then of course, instead of starting at 0, you're going to start at negative 1/3. And then the last one is the end. So all you're going to do in this case is going to take pi x plus pi over 3 equals 0. And then in this case, again, you're going to just solve for x. So that equals a negative pi. I'm sorry, that's not equal to 0. That's equal to 2 pi. So now we're going to write 2 pi in terms of thirds, which would be 6 pi over 3. So it'd be 6 pi over 3 minus pi over 3, right? So I just converted 2 pi to 6 pi over 3, and therefore then I'll just divide by pi. So therefore x is going to equal a 5 pi over 3 divided by pi, which is a 5 over 3, or a 5/3. So then when you just go ahead and sketch your graph, instead of it starting at 0, ending at 2 pi, it's going to start at negative 1/3 and it's going to end at 5/3. The only other thing you need to do is do your x scale, which would be, that's another thing I don't teach anymore. The x scale is going to be where these points come in. So your another intercept, your max, and your min. So all you're going to do for that is just going to take your period and divide it by 4, which equals 1/2. So you'd have to take negative 1/3, you'd have to add 1/2 to it to get to your next x scale, add 1/2 again. It's a pretty messy problem, and this is one I made up, so I'm not sure what the student wanted, but hopefully that helps. Now the next one, we have something very similar. Now this one, I believe they gave me an x. Again, it's not very nice as far as what we have to factor out, but we can go and do that. So first of all, let's go and put it into that format. So y equals 3/2 times the sine. Now again, we need to factor out this b, right? So I'm going to factor out a 2 pi. So again, factoring out a 2 pi is like dividing out a 2 pi. So therefore, that's going to leave me with an x, and that's going to leave me with a minus 2 over pi plus 2. Now, when I'm looking at this problem, I say, all right, am I sure that that is correct? Well, again, when you factor something out, you can always check your answer by multiplying everything back over. 2 pi times x is 2 pi x. 2 pi times negative 2 over pi is going to be a, let's see, a negative 4, which it works out. Now, in this one, I'm not going to go through everything that, but let's go through the stuff that I did in my class. Actually, I'll just do everything. I'm not going to sketch the graph, so that's fine. So the amplitude in this case is going to be the absolute value of a, which is going to be 3/2. The period is going to be 2 pi divided by 2 pi, which equals 1. My phase shift is going to be 2 over pi to the right, which is kind of a weird transformation. And then I'm adding 2 on the outside, so that's going to be my vertical translation. So I'd say up to. As far as my x scale goes, all I'm going to do is take my period and divide it by 4. So that's kind of easy. And then I can do, since this is both a sine, you know, all the initial periods, again, because those graphs go on and on forever, we can just say that the start is going to be 2 pi x minus 4 equals 0. And then the end, doesn't equal 0. Yeah, it does. No. Yep. And then the end is going to be 2 pi x minus 4 equals 2 pi. Okay. So let's see. That becomes 2 pi x equals 4 divided by 2 pi divided by 2 pi. So x equals, let's see, that can be reduced to 2 over pi. And this next one, I cannot combine those, so I'm just going to leave that as a 2 pi x equals 2 pi plus 4, and then divide by 2 pi. So x equals, I guess I could divide everything by 2, so that would give me a pi plus 2 over pi, which could be further simplified, I guess, if you wanted to, as a 1 plus 2 over pi, or you could leave it like that. So there you go. I mean, as far as sketching the graph, that's going to be a pretty complicated sketch. That's why in my class, we just kind of refer to using, the graphing technology. But I still think it is important for, as far as the parts that you want to define, to make sure that you can go and find those. All right. So again, I got 7 questions, guys, for those of you that are in the chat, and thank you very much for helping each other out if you are joining in. But we're about almost to the halfway point, so let's kind of finish this problem. And if you guys do have some more questions, I'll try to see what I can finish up here before I need to go. So the main thing for question number 4 is to isolate our exponent, which is 2 to the 3x minus 1. So to do that, I'm going to add a 7. And then I have a 6 times 2 to the 3x minus 1 equals, let's see, it's going to be 16. Then I need to divide by 6. Now that does not go through, but that does reduce. Let's see, I can divide the top and bottom by 2, so that's going to be an 8/3. Okay, so this one actually works. So I have 2 to the 3x minus 1 equals a 8, maybe it doesn't, 8/3. No, that wasn't right. So now our main goal here is to, going to be able to get the x off as being a power. So what we're going to do that is we're going to use logarithms. So if we take the log base 2 on both sides, so what we're going to do is we're going to take the log, getting slow, log base 2 of 2, 3x minus 1 is equal to a log base 2 of 8/3. And what this does is the rules of logarithms is this allows us to, when I take the log base 2 of both sides, to give me a 3x minus 1 is equal to a log base 2 of 8/3. Now again, I don't have a calculator, but again, just to add this, all we're going to do is add 1, then divide by 3. So x is, once you have access to a calculator here, is going to be a log base 2 of 8/3 plus 1, all divided by 3. And again, that is just something that you could use. You probably want to, unless you have a calculator that does log base 2, you'd probably want to go ahead and use a change of base formula. All right, for question number 5 is the difference formula. I believe, if I remember correctly, for tangent of alpha minus beta is going to be the tangent of alpha minus the tangent of beta all over 1 plus the tangent of alpha times the tangent of beta. Okay, so all we're going to simply do in this case is to identify the tangent of alpha and the tangent of beta. We need to figure out what that is. Now we have the tangent of beta, so that's good, but we don't have the tangent of alpha. So, and how is that in the fourth quadrant? That can't be in the fourth quadrant. Maybe the student meant the third quadrant, or maybe I wrote it down wrong. But let's do the third quadrant because that's important. Actually, it's not important because it's still going to be a positive 3/4. So I'm not sure what this student was giving me, but that has to be in the third or the fourth quadrant. When tangent's positive, it has to be in the first or the third. It cannot be in the second or the fourth. That's when tangent would be negative. In this case, they say the cosecant is 13 pi over 5. Now it's in the second quadrant. And that's very important here because, again, we're trying to identify what the tangent is. So if the cosecant of alpha is 13 over 5, right, remember that's hypotenuse over opposite. And since that is positive, it's going to look like this, 13 over 5. Now, recognizing this to be a Pythagorean triple, I recognize that my adjacent side is going to be 12. But however, we need to understand that's an adjacent side that's in the second quadrant. That is a negative 12. So that's why it's very important, because now when I want to type in my tangent of alpha, that's going to be a negative 5 over 12. So if you weren't paying attention to the quadrants or everything else, you would get that negative sign wrong. So that's why that is very, very important. But for this one, the way I originally had it didn't really make too much sense. All right, so let's just go and do a little plugging and do a little chugging. So tangent of alpha is going to be 13 over 5 minus tangent of beta, which is 3/4, all over 1 plus tangent of alpha, which is a negative 5/12. I think it's really important for you guys to use parentheses here. And then tangent of beta, which is 3/4. Okay, so now we can just go ahead and multiply these. Where did I get a 13 over 5? That's wrong. It's a negative 5/12. Tangent of alpha, right? Yeah, negative 5/12. Okay, minus 3/4, yeah. Okay, so now we recognize if I actually wanted to combine like terms here, all I really need to do in this case is just multiply this by 3 over 3, right? Because then it's going to give me a common denominator. All right, so let's go and work our way over here because I know there's going to be a little work. So we have a negative 5 over 12 minus a 9 over 12 all over a 1 minus a 15 over 36. And then this is going to give us, let's see, we can subtract those. That'd be a negative 5. So that's going to be a negative 14 over 12 all over a, let's convert this to a 36 over 36 minus 15 over 36, which would be 11 over 36. So that can be reduced down because I'm going to do fractions operations, by the way. So I can reduce that by 7. So that's a negative 7 over 6 divided by an 11 over 36. Multiply by the reciprocal. Ah, man, doing so much math. 6 goes into 36 6 times. 6 times negative 7 is a negative 42 over 11. And then I don't think that can be simplified any further. So hopefully I did all my math correct. You guys can let me know. Relic, I like the name. Relic and Ghetto Gamer. Oh, Coffer, you guys are adding in. You're still here. I thank you so much, guys. I really do Appreciate it. And I'm not sure how many questions. I always add more than I always think I can do. So I do have 2 more to go, but I probably have about 15 minutes I can go, or actually about 10 minutes actually. So let's kind of see how quickly we can get these, and then I'll try to get to maybe some of your guys' questions that I can. All right. So the next one says, sorry, I guess I'm tired. So cosine of 2 alpha. So the student wanted me to do some double angle formulas. All right. So here's my triangle. So now I just need to figure out what the cosine of 2 alpha is. So alpha, there's my alpha. So cosine is negative 12 over 13. So we're just going to use the cosine formula, which is going to be, one of them is cosine squared of alpha minus sine squared of alpha. Okay. So we have cosine is going to be a negative 12 over 13 quantity squared minus sine, which is going to be a 5 over 13 squared. All right, so hopefully you know your squared numbers here. 12 squared is 144 divided by 13 squared, which is 169, minus 5 squared, which is 25, divided by 169. And then we just need to subtract here, which is going to be, let's see, that'd be 120, so 119. 20, that'd be 45 over 169. And I'm not sure if that can be simplified, but I would definitely check in some numbers to be able to get to that. But I'm not sure if the 119 would work from there. So now let's go and do a tangent formula. So let's see if I can remember tangent. So tangent is going to be 2 tangent of beta all over 1 minus tangent of beta squared. So this is without me checking the formulas. This is going off just my memory. We taught it last week, so that's why it's fresh. I don't expect my students to memorize this stuff, but I'm pretty sure we're looking good there. So let's see, we have a beta, so tangent. So let's just go and plug it in. So we have 2 times 3 over 4 all over 1 minus 3 over 4 quantity squared. All right, so we're going to have a 6/4 divided by 1 minus 9/16. Now, rather than doing fraction operations like I did in the last one, I'm just going to multiply everything times 16, which is my common denominator. So you can work it either way. And when I multiply 16 times 6/4, 4 goes in 16 4 times. 4 times 6 is going to be a, let's work it over here. It's going to be a 24. And then I have a 16 minus 9, which is going to be a 7. And that looks like that will be our simplified answer. All right, and then the last question is this a function? So the student actually gave me a problem where this was a multiple choice question. And, there's multiple answers for x. And they said, why does 7 the one that makes it not a function? And really just kind of goes into, a couple different ways we look at functions. You can look at as far as the mapping goes, or you can look at it in terms of a graph. And I like to just kind of look at this as far as the graphical approach, because if we plot these points, 1, 2, 3, 4, 1, 2, 3, and then 3, 4. All right, and then let's just do 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, it was, I don't know, somewhere up there. So the point that the question was making was they had all these other numbers, right? And the only number where the x value was the same was at 7. Because the problem with the function is you have to remember, here's like the mapping idea. For every number you get like 1, it's going to map to 2, right? So every function you plug something in, you're going to get something out. So the problem is when you have 7, it doesn't map to just 6 or just 8. It maps to both of them. And that does not work for a function. That is not a unique relationship. So therefore, since the input is the same, but the output is different, that creates a non-function, or that violates here our understanding of what a function is. So therefore, 7 is the only value that would have made that not a function, because therefore, obviously you have the same input, but you have different outputs. So that's why that works. All right, ladies and gentlemen, that is at least it. I do have a couple minutes that I'll be happy to kind of maybe see. Maybe there might be a question or two that might be kind of easy or simple that I can go ahead and answer for you guys. Or if there's just maybe some like non-math, not really non-math, but non-specific problems I can go through. Can't wait till you start to teach high school math again. Yeah, Calc 2. I remember Calc 2. It was a good struggle hater for sure for that. Sure exams f of x equals secant squared of x. I am not sure what you're looking for on that. Looks like you guys have been going through some questions. That's good. All your videos in 2002. Isn't it kind of crazy? Because like some of my old videos, I mean, I was even looking back to one actually my most popular videos at the moment is a video I made from 2010, which is like crazy. You know, like even just the quality or like the instruction from 2010, like it's crazy stuff looking back at some of those older videos. And I guess the way that YouTube is kind of set up, it's going to be like that for a while. Like all the old stuff that I created, it's going to be up there. So yeah, it's going to be kind of interesting from there. All right. Sketch a graph of piecewise functions. Ethan, once this live stream is over, just go back at the first question I did. I covered a piecewise function for you. So hopefully that is correct, or hopefully that helps you out. All right, so I can go through this really quickly. And as far as Brian, how do you study for math? So there's kind of two things that I do to help my students study for math. Well, actually three things. One, I tell them to make sure you guys, go through the homework that has been assigned, right? So I do assign, work for them that I want them to make sure that they know, because it doesn't matter if they go to a tutor, or they, watch random YouTube videos online. People are going to tell them different things that I did not tell them in class, or people are going to tell them how to do things that I did not tell them in class. So one of the reasons that I want them to make sure that they're doing the work that I'm asking them to do, like the notes and the homework, is because that work is designed for them to do better on a test or a quiz. Math is a very, very expansive subject, and people are going to, maybe when they took pre-calc, they'll say, hey, let me teach you all this stuff, and it might not be necessary for my class, or not. It might be something that, we're not covering for this exact quiz or test. So that's why I always tell students, make sure that you're covering the work that is designed for the course, number one. Number two, as far as like studying, is, make sure you're just, doing as many problems as you possibly can, like problems in the back of the book, redoing problems that you were given in class, like examples, covering up the answer, working those out, and then checking your answer. And then if you didn't get it right, doing it again, going for that. And then also one of the techniques that I learned in college was just to write a cheat sheet, write down all the formulas, all the methods, examples of all the problems, and pretend that you would be allowed to have that cheat sheet on your test. Like, what would be everything that you'd put on that sheet of paper? And what that does is that allows you just to kind of go through all the information that you have learned, and add and subtract things that have been beneficial or that would not be beneficial for you, working into a test. So hopefully that is advice that will help you guys out. I don't know why my voice is starting to go. So I thought I saw some more things. All right. Well, how to find the period of sine and cosine. Steve Lewis, I do have some videos for that on the how to find the sine and the cosine. Yeah, I just did some of those videos, or just did some of those problems for you guys on that. And Rose says, Brian, is the study for math usually based on preference for the teacher? Redoing problems sometimes work for me. My problem is that I am not consistent. I am not sure. Is studying for math usually based? I mean, I'm just telling you, not really based on my preference. I'm telling you how I went from a student that really, really struggled with math to, how I got my math degree. So really my advice to you is not really from a teacher. It's really from coming from a student, and maybe I'll just leave you with this piece of advice. I think one of the best things that I learned to be as a student was to talk to my teachers. Every teacher has their own little quirks, the own little way they want things to be, and stuff like that. And that's just being, teachers are human. They're all different. They all, have certain things that they are all different expectations and how they handle things. So, I think one of the best things that you can do is, ask your teacher as well. Like ask them the same question. I mean, I'm going to give you advice, from, yes, it is impacted from me being a teacher, but it's also being from, me being a struggling math student, not understanding math and struggling in my classes and, trying to work my way through that. And that's how I've developed a lot of things that I teach you guys online, as well as in my classroom. But I also think that, just going up to your teacher and saying, hey, what would you recommend I do to study for this test? How can I get better, in this class, or how can I be successful in this class? I think those are great questions to ask. And I would love for any of my students to be asking me those questions, and not from a standpoint of asking them just to get a better grade, but, for that pure fact of like, I want to do better and I want to do the best I can do in this class. And, I think your teacher, hopefully your teacher, will, give you some good tips and some good advice to, help you go through. So, all right, guys, I think that is a good end for the live stream. I am kind of at my end. I'm still kind of covered over a little bit of a sickness, and so I can just kind of hear my voice kind of going. But I do appreciate you guys going. I do go every live. I do plan on going live every week here on Sunday, 9 p.m. So look out for, again, that community chat that I like to post on Saturday. So therefore, if you do have some questions that you'd like me to ask, you can go ahead and post them, write them in there. The more specific that you are as far as what you want me to talk about or explain, or the general problem, then I can go and do it from there. Otherwise, I sometimes will ask further questions, or I just won't be able to get to it. If it's either a topic that I just don't feel comfortable explaining, or something maybe I haven't taught before. Usually I'm not going to cover if I haven't taught it, I usually don't want to give an explanation, because I don't feel it's going to give the best justice to the explanation of that problem. But otherwise, I try to do my best to give you guys I'll try to do my best to, cover everybody's questions that are presented, and I'll look forward to you guys on the next stream. All right. Thanks, you guys, for joining. Have a good night. Cheers. Now I got to figure out, because my old thing used to work. So, says end stream. Let's hope.